I'm going to make a quick introduction, and then Daryna is going to start her presentation, and then we can do questions at the end. So I hope you can hear me. So quick introduction. She is a postdoc researcher. It's also research computing lab in TUM. She did her PhD in Skolkovo in Moscow, and she's gonna present to us a really interesting subject today about social good NLP. And I would just suggest that maybe we listen to the end, and then we can do a Q&A session if you want, if that's okay. Okay, so the stage is yours. Thank you.
Yeah, thank you very much for introductions. Yeah, I'm sharing my screen. I hope everything is okay. If you can see everything, just let me know if something is wrong. Yeah, so my name is Dementieva, and indeed I finished my PhD just super recently, maybe a month ago, and my topic was connected during my PhD studies with several aspects of NLP for social good. And in TUM, right now I'm a postdoc, and I'm trying to continue also this direction of research. But today I will tell you the interesting findings that I found during my PhD studies, and we will talk also more closely about fake news detection and fighting with toxic language. Yeah, so the motivation of my research was that indeed today we have a very diverse amount of different models, and yeah, so if we look retrospectively at what was done in NLP in terms of models for transferring words into vectors, we can see that before it was a quite simple baseline models based on different count-based models, and they didn't take into account very much the semantics of words. Afterwards, there was created a word-to-vec model that now can take into account semantics, and even we can do this very funny and also useful vector mass. And recently, there was introduced transformer model and transformer architecture, and there was used a lot of transformer-based architectures for NLP and for image capturing, for example. And now these architectures are more not just semantic based, but also context based. And yeah, so thankfully we have right now the big platform Hugging Face, where we can have and host and download and upload all these models, and they achieved quite good results. A lot of based on different data sets and different tasks. So yes, you can see the list of the models that I will like use in my research and that I will talk about today. And I believe that all of you are already familiar with these models. And the first version of the models were monolingual, but recently also we have different multilingual models, and also their perspective of what is done already until today. Yeah, so we have different multilingual versions of BERT, of D5, of BART, of Roberta. And in this year, we have quite big and good models from Bloom and from Meta, so research, and which is called No Language Left Behind. And these models are quite big, and you can even see that the last model covers already 200 languages. Yeah, so the applications, of course, can be, first of all, quite straightforward, just for machine translation, for example, and also for vectorization of text in different languages. But of course, there is direction in NLP and artificial intelligence in general that tries to think about how all these advantages can be used for social good. And yeah, so for artificial intelligence, there can be different directions of how AI models can be applied. And here's like the diagram of what are the main directions in which artificial intelligence models are explored, where they can be applied. And yeah, it can be really super different from climate to cities, also working with text, agriculture, healthcare, education, and also different solutions that can help us to respect equity. And for in NLP specifically, there is a special even like kind of volunteering organization or a group of academics that think about how NLP can be applied for social good. And there is a special even website, so you can visit and take a look. And yeah, so the whole the community is dedicated to search for solutions, to search for communication, not only within academia, but also with people from different areas, from social working, for example, area, from some governmental area, and etc. So to look for problems and for solutions for these problems. And of course, so the last point is also very important. So not to introduce new forms of harm and think about how carefully can be applied to any artificial solution. And so also we thought about different different perspective how NLP can be applied for social good. One of the examples can be health use case, where, for example, a person can be so depressed, can have some psychological problems, and unfortunately, for example, in some countries, there can be a case that is quite long to wait for an appointment with a psychologist, but we can create such a helper, such bot based on different NLP models that can just for some time support the user and at least help to talk about the problem, because people sometimes can be also embarrassed to talk to a real person about his or her problems. So there can be also a case how we can use our NLP models. Also, for example, in education, if we have some text and the person trains his or her language, so new language, and there can be a case that the person can misclassify the context of using the style. And so for example, there is a letter, but it's supposed to be an official letter, and we can ask a model to identify which parts of the text are not correlated with the context, and which style is incorrect right here, and also to generate explanation why it's not correct and how this sentence can be changed. And for example, for equality, also, for example, in conversations, in chatting, in comments, in social networks, if there is a case where the conversation seems to be not very fair about some minority group, or for example about gender, so that also can be just a helper that can point out about this problems, this issue, and explain why the conversation, the claims should be more fair. But this is really just an idea. So of course it's not how it should be implemented directly. So it was just a fantasy about in the community how NLP can be applied. But in my work, I focus more about the fight with harmful information use cases. And we can think about different types of abusive language and about different types of disinformation. And specifically, my research focuses on toxic language and fake news. So after all this discovering of all different this zoo of model NLP models, there was a question: so how can fake news detection benefit from multilingual models, from multilingual evidence, multilingual texts, and what NLP technologies can be used to detoxify text? And which one, monolingual, multilingual, which can be applied, which can be better or at least useful somehow? And that was the exploration in these two research questions. So the first part is about fake news detection, and I will give you an idea of our pipelines that we created and how it works today and what will be the ideas for the next step of our research. For just introduction to the field, so what is the problem of fake news detection? We have an article, and this article can be a text. Also, there can be a text with an image. We can have also some information about the source. Also, we can have information about how this use was published in different social networks and how it was propagated and expanded and explored. And we want to identify if this piece of use is real or fake. But there is indeed a question how we can define this feature representation of the use. So on which information we should build our decision. And the first direction of model development is to build classifiers based on internal features. So we only focus on the text or on the images and the source of the news that we have, and we can calculate different statistics about the words present in the text or punctuation. If, for example, the words are in caps lock or not in the caps lock, so it can be like clickbait case. Also, we can take a look on the emotions that are used in the news. And so this is an idea that maybe if the news is fake, it tries to fear the users and to gain some negative emotions. So we can check the correlation between image and text, if it's really about the same event or it's some just random image or random text at the same time, and if the source is trustable or not. On the other hand, we can look into external sources, and we can take a look how the news was published, at which time, how many users liked, shared the news, how fast it was propagated in the social network. Also, we can just look for just indeed like do the search, for example, Google search of the news as a typical user can do, and just check what is written around the different media and all around the world. And yeah, so actually in previous work, only monolingual search was used, and yeah, our work was to change this gap and to actually use multilingual search, and to look if it will be beneficial or not beneficial for package detection. And yes, if we even talk about the data sets, so we can see, so yeah, of course, on this in this table, not all day-to-day fake news data sets, but anyway, the tendency is that for English language, it's really quite an amount, privileged amount of data sets in this language, and not even for any other language, the fake news classification data sets at least are present. So of course, if we want to do the system for any other language, it's quite difficult to transfer this knowledge. So either we need to create a data set, or we need to somehow try to translate, maybe use some translation. So yeah, it's like work needs to be done somehow. And we also wanted to think about how this any pipeline or any feature can be extended to any language with zero-show setup. So the idea, based on the hypothesis that if the news is true, it will be widespread in different languages and also across media with different biases in the facts, but the facts mentioned should be identical. And on the other hand, if the news is fake, it will receive a much lesser response in foreign press than true news. And of course, if we think about the hypothesis, it will work supposedly with global news, so which covers global events, famous people that are known all around the world, or at least at some region. And we won't look at some local news. So we will work with widely widespread news. The idea is as follows. So for example, we have some news article, and we extract the title of this article, and then we translate the title into several languages and do search, some retrieval of the knowledge from different languages. So the previous step is to check if the information from scrapped news in different languages correlates with the original news. Is it similar, not similar? If there is some contradictions already written, or there is just no information connected with the original news. And if there is not so much evidence, not enough evidence, or even if there is contradiction, then with high probability the news is fake. On the other hand, if there is a lot of support information, then with high probability the news is true. And yeah, so we present such feature that can help us to understand if the news is fake or not. And yeah, so it was checked firstly manually, and then we tried to extend to automatically scrap such news results, and we used we used quite typical services to do this. So for translation and search, we use Google services. For languages, we focus only on European languages: English, French, Spain, Russian, and German, and also we scrapped 10 search results per each language. And for comparison between so this is the whole pipeline. And also we take into account the ranks of the sources of this scrapped news, and to comparison between two news in different languages, so cross-lingual news similarity. We also use the cosine distance. So we embed the titles of the news with mbert and calculate cosine distance, and to transfer this distance into 0, 1 labels, we fine-tune hyperparameter for this. And we checked our feature on 3 data sets covering different topics, so sports, business, entertainment, also rumors about different celebrities, and even the latest news, like latest to this time news about COVID-19. And the baselines was, so also we took into account just internal features based on linguistic features. We tried typical classification models, neural networks, TXN and LSTM, also transformer models, version to version, and also we just look only on lingual evidence, not multilingual evidence at our feature. And we tried it just alone or in combination with all these different setups. And yeah, for abbreviation is detoxification task. So we used F1 actually as the main measure to compare, and also we statistically identify our results. And as you can see, so if we add our feature to the models, so the improvement is quite high. So here we can, yeah, so we can see that the best models anyway are concatenation of transformer-based embeddings with our feature. But also, what is interesting is that concatenation with linguistic features, it also works quite nice. And actually, these features are even more explainable than transformer-based embeddings. And if we look at our feature just alone, so anyway, it's in the majority of cases even better than the baselines. So it can be also used as quite a good zero-shot feature-based model to detect fake news. Yeah, so actually, anyway, this research was, so all previous results were not on so big data sets, and it was like kind of like MVP models. And of course, there are research questions left in this task. And one of them is how to create more stable measurement for comparison between different multilingual and cross-lingual news. And I just want to leave here a description of competition Semoval previous year that was dedicated exactly for this task. So how to compare information in different news in different languages. And it covers quite a good amount of languages, so not only European, but also Asian, and yeah, so quite big amount. Yeah, so the competition is to create such metric and also to compare it with human annotation, so based on critical correlation. And I think it's really very nice still to explore the data set and still to think about the metric. Also, so due to today's events, it's quite interesting to think about how this can be applied really to ongoing cases. And one of them is Ukrainian-Russian war. And right now we have a project in our lab, so we will try to take a look at this, yeah, this use case, and maybe in several months we can take a look at what we will scrap for this. Yes, of course, the very high goal is to create such system where the user can type his or her research, so his or her news that he wants to explore, and then we can get different results from different languages, from different countries, so from different perspectives, and explain the user why this news supports or refuses, or what are different views on this situation, so the user can be more critical at least. Not maybe, yes, quite difficult to say with a very short time if the news is fake or not, but at least we can show the different perspectives and try to make the user to be more critical about the information and to think about, so yeah, maybe something is he or she should believe right from scratch. And yeah, so you can assess our courses already published about fake news, about the metric, and also even the demonstration that I showed is also available online. At least you can try to play it with it. It's not ideal today, but anyway, it works already somehow. And yeah, so another part of the talk is the detoxification part. And yeah, so the idea is, unfortunately, also right now in different social networks, or in conversations during, for example, games, people can be toxic, and people can be offended or then can be aggressive about some opinion. And even right now, different social networks, they try to fight this language. Even Facebook, Instagram, they already have some filters. But anyway, these filters only bans messages, and of course, to some extent, it's a solution. But for example, if we blocking the message of the user, we can at least try to show him or her that yes, it was toxic because of this and these words, or because of these phrases. And here is an example how you can rephrase, how you can internalize your sentence, and with which sentence you can send. On the other hand, yeah, quite not so human-oriented example that different also chatbots can be trained on open data, and already there were cases from big companies where the chatbots were pre-trained or fine-tuned on some additional data, and they became quite toxic. And yeah, of course, it's can be quite dangerous for reputation of the company. And the case can be that also we can filter such sentences and also not just block the conversation because it will be strange from the user side, but try to send a neutralized version of this message from the bot. And yeah, so this task can be solved as a text transfer task, so detoxification task. And the task is to create such models that will take as an input some input text with in some style, but we want to produce a new text within a new style. And we want to measure that, we want to ensure that indeed the style was changed, and we can do this with some classifier, for example. Also, we want to ensure that the content is safe as much as possible, and we can do this with some also similarity function and measure it with some threshold. And also, of course, we want the resulted test to be fluent. And also, it can be some classifier or some functions that will measure us to some extent. In terms of the task of detoxification, what we want to achieve, again, roughly speaking, that we want to eliminate toxicity. We want to save the content here again as much as possible, because, for example, there can be a case in textile transfers that the content is not so important, but in our case, it's quite important. And also, we want results to be grammatically correct. And here, yes, the examples what we want to achieve with our models. So talking about the text transfer task in general, all the approaches can be divided in these two parts, unsupervised approaches and supervised approaches. And the difference here, main difference is about data sets that are available. And of course, for the majority of styles or text classification tasks, we have indeed such text classification data set. So we have only two classes to label or any other amount of classes to label that can, for us, distinguish some style, but anyway, the samples are not parallel. And the majority of the work, previous work, are based on this data set because, of course, yeah, they are available, they are already built for classification, why not to use them and why not to build approaches based on them. On the other hand, if we are lucky and if we have some parallel data sets, of course, we can refer to this task as machine classification task and build just our SQL models that were also very powerful right now, and then yeah, do this text generation task for text transfer. So if we're talking about unsupervised approaches, what exists today? One of the quite simple solutions, baseline solutions, is of course indeed just delete words for some style. For example, in our case with toxicity, we can just delete toxic words. We can predefine some vocabulary for English language or for any other languages, and then just to delete this word from the sentence, and this is it. But of course, it's on one hand very difficult to maintain all the root words in the language, and of course all different forms of these words in the language. And if we just delete such words, it can ruin the content of sentence because it can be something important. And also based on solution for this, we can try to find some phrase from, for example, neutral part of the data set that is kind of similar, for example, by some similarity to the original phrase. And yeah, so here actually the link, the reference to the paper that a little bit more explored this approach and built not just substitute only just a phrase from the data set, but also tries to build a model, RNN model, to generate more fluent samples here. But it's quite anyway here baseline model. Also, what can be used, the power of masking language modeling can be used here. We can, for example, also train a model that will define for us which words in the sentence in the phrase refer to the original style, and then mask these words. And as, for example, BERT model was trained on one of the tasks is to predict the word for the mask. So yeah, pretty simple. And we can also pre-train the model, language model, to substitute words with specific style and use this modeling for text transfer. And also in our work from our lab, we kind of explore this approach. And yes, in this approach is a question how we can rerun this substitution. So it will refer to the style and also the content very good. And we explore such model in our work, and we use first so firstly we paraphrase the sentence with the paraphraser, and then we apply ranking of classification model for toxicity, and also substitute with normal model just to run this course. But yeah, again, if we're lucky and if we have a parallel data set, we can refer to the task as a task. But here also we can use different setups. For example, we can just show the model with prompt what we want to achieve with this paraphrasing, with this translation. And also, of course, we can just tune this model and then luckily use this model for our task. But what is problem here is actually the set, because actually for text transfer, there are not so many data sets that are parallel. The biggest of them are Bible data set and GR data set, and they are about transferring first style for Bible, but it was collected during the centuries while people were rewriting Bible. So GR data set is about transferring formality, and the authors actually collect the samples, so collect paraphrases with Amazon Mechanical Turk, which was automated. But anyway, here they then manually by themselves verify the quality of the samples in the data set. So it anyway required quite a lot of time and effort to do this. And for toxicity, we have, for example, for English language, quite big data sets for classification, but anyway, they are not parallel. And in our work, yes, we wanted to address this gap and to create such data sets that will help us to detoxify sentences quite good. But firstly, we have to create such pipelines that will collect this data automatically. So we wanted to create such pipelines that for each sample, we will gain several paraphrases. The content of the paraphrasing samples will be the same as possible to the original sentence. The style will be non-toxic. The samples will be fluent, and also the quality of the samples will be checked not manually by experts, but automatically somehow with crowdsourcing. So actually a very important point here to mention is which types of toxicity will work here, because there are several labels even in the data set, and they are quite diverse. And yeah, you can see here some examples. But if we think about some samples about some type of toxicity, and if we try in our head to identify such instances, we will understand that it's quite difficult to do this, because sometimes the content is toxic by it is, and to detoxify it, we need to change the content. So we need to change the similarity between the original sentence and between the paraphrasing one, and it will be quite difficult to maintain the similarity between these two samples. So we work only with Z samples. It will be quite obvious how to detoxify it. So it can be indeed just written off for toxic words, but or somehow rephrasing the phrase. But anyway, the content of the sentence is not so is more general, so it's not so toxic. So we don't have to change the main content of the sentence. So it's So these mostly two types of last types in the table. First of all, what we have to do, we need to change the data set and to check that we work only with sentences. So it's quite difficult to paraphrase the whole comment if it's about the paragraph. So we want to work only with sentences, and also we want to work with like middle-sized sentences that are not too short, because mostly sometimes it's just only the root words, and it's often not too long, because it can be just difficult to rephrase very long sentence. Then, of course, we created a task that will ask to generate a paraphrase, non-toxic paraphrase. Of course, there can be a case that sometimes we anyway have some non-toxic sample here, or it's anyway too meaningless, or it's too offensive, or again, it's some sarcastic or passive-aggressive sample. So of course, the user can label here that he or she cannot do this. But at the same time, there is a text field, and the person can write here whatever he or she wants to write. But we want to verify the quality of this of our samples. So that's why we didn't pay here like at the glance of fulfillment of this task, but we do a delayed payment. So firstly, we of course verify our samples, and the second step is to check if the content is indeed the same with our original sentence and new sentence. And if it is not, unfortunately, so we deny here to pay for this sample for the first task. But if everything is okay, so we go to the next step. And the next step is indeed to check the style. And again, if it's not correct, then we do not pay for the sample for the first task. And if everything is okay, we are happy to have the sample in our data set, and also we pay for the first task. And so the whole pipeline looks as follows, and we call it part of docs. So it helps us to collect parallel data set for detoxification, but actually theoretically can be transferred to any style. Also, we check this transferability not for the style, but for other languages. So firstly, we created this pipeline for English language, and we tried for Russian language. And so yeah, the main point here is indeed to collect this classification data set. So it should be exist for language, of course, to at least at some amount, 100, 200,000 samples, but at least something. Then we fine-tune classifier to just filter these samples, what we want to put as an input to the pipeline, and translate the interfaces, of course, adapt training tasks to explain what we want from the annotators. And yeah, so actually that was the only step to do. So also it can be theoretically extended to any language. And yeah, so this is actually publicly available, and English dataset is at Hugging Face and Russian at GitHub, and it can be used already for detoxification or for any other research purposes. So here are just some examples of what it was changed, and of course we also manually verified that the pipeline worked. For this, we collected 200 samples from each dataset and just manually check if this was correct or not. And yes, so the validation shows that only less than 10% of inappropriate samples, so it's quite good working pipeline and quite good working data sets. So yeah, and also example for Russian. So if you have any Russian speaking, I don't know who watch right now is a lecture or later on YouTube, so you can take a look at this data set as well. Also, just illustration how people indeed substitute toxic parts. Sometimes indeed people just delete toxic words. It can be a case, or they do literal paraphrases. On the other hand, they can somehow smartly or more literally paraphrase the part, or even paraphrase the whole sentence. So it also showed us that it's not enough just to delete the word, but it's really a cases when we need to paraphrase, we need to do paraphrasing here, we need to do it in more complicated way, just deleting or substituting with some phrases. And for this, it should be better to use some advanced text generation models. So that's actually we tested in our different research parts, papers for different languages, for Russian and English as well. Also, we thought about, I mentioned here about masking models, and actually we created such a baseline for unsupervised approach based on BERT models. So yeah, as I mentioned, so we can detect some toxic word in the sentence, then mask it, and then ask a model to substitute it with some vocabulary. And a trick here was that we actually trained a quite simple classifier for toxicity detection of tokens. It was based on logistic regression, and then we rerun the whole vocabulary of BERT, and that helped us to substitute words with neutral style. And yeah, in the end, we can get quite neutralized sentence. But anyway, the problem here and the question here is how we can generate this substitution still from BERT vocabulary. Simple baselines that we just duplicate the sentence. It's only just for cross-check of metrics, and yeah, delete the words from predefined vocabulary. Also, all previously mentioned models were used as a baselines, and we used the GPT, T5, and BART models to look if our hypothesis of using parallel corpus works or not. About evaluation, so I will just mention here. So it's quite a also topic and research question to explore in this field of text transfer, because still in different papers and different literature, there is no one metric to use for any text transfer task. But anyway, so the parameters to measure here are anyway the same all across different works. Anyway, we want to ensure that the style is changed, so with style transfer accuracy or classification of the style. Also, we want to ensure the similarity of the content is quite enough, and it can be done with cosine similarity, for example, or classification model. And the fluency is also enough for our task, and also it can be done with some classifier and a joint score, so just for the one measurement between all the models. And yeah, so also again to mention here, since anyway there is no one a solution for all these models, and still there is a research between correlation of automatic evaluation and human evaluation, and Still, the correlation is quite low, but anyway, we can use some classifiers just to estimate if models work adequately or not adequately for our task. And here for English, we have classifier Bertrand and Roberta trained on Jigsaw. For similarity, we use cosine similarity at this point of research. Also, for English language, it's quite easy to build a fluency classifier because there is a very nice data set for English stability called COLA. And for joint score, we have so this formula, and I will explain what does it mean. So for all these three parameters, we transfer each to 0, 1 values, just to see if sample failed in one or other parameter, and if it failed, then it's not good enough. So we will multiply all three parameters, and if just one of the parameters is 0, it will be 0 for the whole sample, for the whole validation. And then we just calculate the mean between all the data sets. And to compare the similarity between the output of the model and the human references, we use blue metric. And for, we also, as I said, because the correlation is quite low, we also did manual validation, and basically we somehow repeated the annotation process as we use for collection of a data set, and also we checked if the text is grammatically correct. So we add new task here and did the evaluation with crowdsourcing. So yeah, for English language, we have such results. And what is important here is that, so the duplication, of course, failed in indexification, and zero shot actually setup of a different generative model also failed, because anyways, it's just simply paraphrase or duplicate the original sentence with no deduplication purposes. Also, so this baseline model from the generate paper is quite good and have quite a say because they were designed to insert toxic parts, but in terms of J-score, anyway, results quite low. So delete is anyway quite nice. Still baseline if it's even quite simple, and it outperforms any other more sophisticated baselines. But the best, was the models based on mask language modeling, and they work quite good. But anyway, here they have still some problems with fluency because they can substitute mask of words not so correctly and not in perfect form for the sentence and for the content. And if we look at on our models, so yes, the usage of parallel data set, of course, helps to improve the performance on the task a lot. And yes, also if we take a look at how actually many samples we need to use, so the answer is if we have 10,000, 12,000, 15,000, we should use as much as possible. But anyway, there is still a question of how we can smartly collect the data that will gain for us the diversity of toxic samples in the results data set. And if we also take a look at the samples, we can see that in manual evaluation, the gap of the score is really very high. And so if we look at the results from models, we can see that sequence models trained on our data set performs very nice for this task. Also, as we had two data sets in two languages, English and Russian, we also tried multilingual setup and cross-lingual setup. So we wanted to check firstly if we train a model on both parts, on both languages, if it will be enough, and if it will indeed detoxify samples in two languages. And also we wanted to check how we can transfer the knowledge of toxicity to any other language. So we use for our experiments MT5 and MBART models. So that are very quite big models. So we're covering, so MT5 covers 101 languages and MBART covers 50 languages. So it's quite big amount of languages to cover. And so there is a table with so many numbers, but what we can see here is that overall, if we want to do multilingual setup and we want to do multilingual classification, we have this parallel data sets for all languages, then it will be quite successful. The results are a little bit worse than for the monolingual models. So if we train it separately for monolingual models specifically for the language, but anyway, it's quite high, and it can be so we can work with this. But if we look at the cross-lingual results, so anyway, right now it fails, at least with our experiments. So if we train some model in English language and want to somehow tell the models if we want to do detoxification in Russian language, it's just not possible now. But we saw works that already did somehow such experiments for formalities transfer. So maybe there is promising direction to use adapters to this task. Yeah, but this will be a future step in this research. And actually, we also built system demonstrations, so they are accessible online, and in Telegram there is a bot that also actually can work with languages. And yeah, so you can play with our models there. Yeah, so the models sort of for English and Russian are out in Hugging Face, and yeah, so the links are for demos are here. Yeah, so future directions, so what we want to achieve in our future work, of course, is to cover more languages and as much as possible, as many as possible. Of course, there is still questions, post-doctoral, for example, how it is similar or not similar to any other language. Even for English and Russian, of course, we can see differences, how people express themselves, how people use toxic parts, how people even then rephrase these toxic parts. So anyway, it's a challenge, but yeah, we want to cover as much as possible. And of course, we want to work with more deep type of toxicity, because as I mentioned, that we work only with kind of like obvious types, but to work with sarcasm, with passive aggressiveness, with racism, sexism is also will be very interesting. But anyway, very challenging. And also there will be a nice research to think about how we can smartly collect samples, so our data set, because if we even trained and even we collect a data set, part of talks based on the data sets from Jigsaw that were from 2019 year, for example, the latest, but yeah, so the language is developing and the type of skill is developing as well, and we want to somehow update our models and somehow add these new samples, and we want our model to be aware that it hasn't seen these samples before. So also actually learning will be quite a nice direction to think about in this direction. So yeah, thank you very much for your attention. Here are several links how you can contact me. Also how you can, we can visit Hugging Face page of our institute, where all the research, so models, data sets are published. And also you can check the recent research at our lab at TUM. And the full text of the thesis is available online, so there is a link. So yeah, thank you very much. And if you have any questions, so there is time to ask them.
Thank you so much. This was really interesting. I was about to post the link to the PhD, but you already did, so people can go check it out, and they can go follow you on Twitter. So I have some questions. Can you hear me right now?
Yeah, I can hear you. Yeah.
Oh, okay. So I would start with, I mean, you quickly mentioned it at the end, so I guess this would be kind of a more question about a future direction. But a few years ago, I had to write purely linguistic paper about sarcasm and humor, and it was extremely challenging to even define in formal terms what even humor or sarcasm is. So how would you think that irony, sarcasm, humor would have to be handled in this context? And is there any way to differentiate between harmless humor or even edgy humor and pure hate speech? And maybe what type of architecture can you think about formally to implement to differentiate both?
Yeah, so I can refer to just open like a slide to have this list of possible types to work with. So I can just tell, first of all, my experience, how we work with this, with our task, and we had in competition previous year. And yes, so firstly in our lab, for example, we created these instructions to do crowdsourcing, and somehow, to some extent, we all were at the same page, because even in our lab, it was discussion how to understand that type of statistic with which we worked before. And then also when we had competition, and then we will publish our data set and the task to participants, even afterwards, after instructions, after samples, examples, there were questions anyway about so how we can define toxicity, how we can work with it, how we can understand this. And we really put a lot of effort to explain it so at least 20, 50 people can understand this. Yes, but this was for, I can say like simple types of species that are obvious. You can see this toxic word, root word, and you need somehow to rephrase it, and yeah, it will be just done. So for sarcasm, for irony, yes, there are data sets for classification. And actually, personally, I didn't work so deeply with data sets, but yeah, I anyway worked with hate speech and a little bit with propaganda, actually, somehow related that even I can understand. So even as a person, when I read these samples, I don't understand sometimes by myself why this sample was labeled with this label and not with another label. And so, yeah, the first step in this question, how we can handle these types and create some textile transfer task for this, is anyway to dedicate a lot of time to anyway differentiate for yourself or your research group how you understand this or that style, because this is really the core thing in this research. Somehow to formalize, of course, it's not very good formalization, but anyway, if you at least have very good examples to illustrate what you want, with which types you want to work, anyway, it will be something. So about the models to classify or to transfer style, yeah, I think it will be, if you manage to build a very good data set, at least again, so will differentiate samples, so there will be not a mixture between classes. Of course, you can apply just any modern architecture right now, but I think it's not possible to create such clear data sets, of course. Yeah, so anyways, the question will be, and the solution will be data. So if we can somehow try to evaluate uncertainty estimation, yes, for not at the model level, but at least at data level. So I think it will be somehow, if it can be somehow incorporated into a classification model or generation model, it can help us a lot. But yeah, anyway, here, so the question and the answer is in data. So if we can dedicate enough time to have more clear data and to understand some type of toxicity or any other harmful language more, so yeah, of course, it will be very, very nice.
Thank you. I think this takes me to the next question, which is kind of more general and philosophical, of course, but I think this is very natural with this type of subject, which is super interesting. What is your opinion on how much responsibility, because obviously none of us are governments, politicians, and so on, or we're also not companies, but we are NLP researchers, data scientists, and so on. What do you think is the personal responsibility of NLP researchers and so on to make sure that this kind of technology doesn't get misused in some way? And is there even a way to make sure, maybe through open source, or just or is it completely out of the normal people's hands, to say so?
Yeah, so thank you for this question. Actually, when I talk about this topic, yeah, when I talked about this before in the conferences and during my PhD and even after my PhD as some other research groups, so this question raises every time. And yeah, so of course, so the first thing is that yeah, I mentioned this NLP for social good initiative, but I think right now there is anyway a very good direction of style of publishing papers in this ACL community. So all these at least higher end conferences, and there is right now a requirement that when you publish a paper, you need to put an ethical consideration paper, so ethical part that will discuss your discussion or from the authors, for example, of the papers that so you can think about how your technology can be used or misused, and what are the can be harmful sides of the technology. And I think even there is like a special committee and special reviews, so not just general reviews but also ethical reviews, like a special community of people that do this review of the paper. And so from the community side, I think it's very nice initiative that check, at least cross-check, and at least can raise new discussions between authors and reviewers, so between community, in community about the technology that authors want to publish. And yeah, so this really helps to think about and ask these questions at least yourself. So how this knowledge can be used or misused, who can benefit or who can be harmed with this type of models or technology or applications. And yeah, so at least from academic side, there is already such solution. Also, of course, I think it was maybe because there was before a tendency that just we wanted to build some model, we wanted to gain some very high F1 scores, and we don't care so much about how it will be used by companies. But yeah, anyways, through the years with this raises of very powerful models, it has changed, and people really think about so how it can be used and misused, as you said. About personal research, so personal research perspective, direction, how people organize their research, what we can think about here is that at least when we doing some research with master students or PhD students, of course, we just also need to educate them that, yeah, of course, we need not just to build a model, but we want to think about the applications of the model. And yeah, maybe with this initiative of NLP for social good, people also try to raise this question, at least on personal perspective, that people during their research, during their studies, will think about not just how to build very good model, but also to think how we can apply afterwards it. And secondly, third thing that, of course, it would be nice if we have this communication between industry and academia, and because I think maybe companies don't have so much time to think about how ethical or not ethical can be a model. So it's more maybe a task for academical people to do this. And if we have this better platform for communication, for somehow consulting, or for how we can use that or this solution, even for the detoxification, for example, yes. So somehow it was also dangerous to publish this model online. It was useful from one hand because, of course, we have this community, and community checks these models, play with, and people tried even to read these instructions to identification of our task if they understand it correctly. So, of course, there's questions about how we can use it, for which type of toxicity, how we can misuse, because even also during our competitions, there were people that trained detoxification models, so the models that did reverse tasks. And yeah, it's kind of dangerous, but not so much, of course. Anyway, here, yeah, so publishing in detail code and research online really helps a lot. And of course, these discussions about if this task is useful or not, it's already a discussion, and already it can, even for people that work with this type of problem, think about if it's indeed useful or not. But on the other hand, of course, this online available models, and any company can just take it, and because it really works quite good, at least with general sentences, and companies can just take and use it. Of course, the license, as I believe we published it not with commercial use, but anyway, yeah, so you can replicate the model, you can replicate the pipeline, you can replicate the dataset or some idea, and anyway, it can be used. And for example, in the papers and in my work specifically, we wrote about the use cases and about the framing of these models into the interfaces, how you should not irritate the user by just blocking and by just substituting the sentence in the neutralized form already. Of course, it should be just a recommendation, not an obligation to do this. But yeah, so anyway, there can be a danger that these models can violate somehow freedom of speech. Yeah, so it's really a very philosophical question how we can solve this problem totally, and how we can live in this very progressive world where we can indeed track how all our AI models are used. And yeah, so what can I say? Indeed, from academic perspective, I can say that indeed this direction of adding at least ethical consideration in the paper is already quite a good step when people do the research and they can think already so yeah about the pros and cons of the models that they created. Anyway, so yeah, if you have also any ideas how it can be done for a broader community, it also will be nice to hear, because even for this research for detoxification, even for myself, I am still wondering how it will be a nicer way to publish it and to talk about this problem.
Thank you. I see that you've been asked this question many times, probably every time. But yeah, also the subject about toxification is super fascinating, because it opens the door to so much, misusage and propaganda, and it's super fascinating. It's also kind of funny if you think about it, but this was a very interesting answer. we have a few more questions. So if anyone has any questions, I would ask you to put them in the chat on Zoom. And in the meanwhile, I'm going to move to a question about initialization bias. Can you recommend some papers on this topic? How does the initial data affect the target task? For example, sentiment model trained on Wiki with sentiment model trained on Reddit, for example.
Yeah, so actually about this, about bias, so there is a nice paper. So again, we're referring that a lot of problems we have in the dataset themselves, and not even the dataset, but also in the instructions, in the annotation design, and even people who do annotation. And there is a recent paper, as I remember from this year. So one of the authors is Martin Sapp. Why I remember this person? Because it also he also did a lot of work in this direction of human NLP for social good, in toxicity detection, in also I believe sarcasm detection. And there is a recent paper, I don't remember the title exactly, but it is about how bias can be annotation and annotators themselves. So the idea is, for example, if we want to annotate the data about hate speech, for example, and we so gain some corpus, gain some samples, whatever, and then we ask people to do this. And if we just do this blind crowdsourcing, we will gain quite, so of course some labels, but there is no guarantee that there will be no bias. And the bias can be, for example, from the size that if we have some hate speech sample about some minority group of people of color, for example, and if we have an annotator, as annotator, a person who is roughly speaking, so white person from Europe, and he or she just doesn't understand why it can be hateful or racism. But of course, if a person of color from a minority group will read the sample, it will he or she will clearly understand why the samples would be hateful. And so even this design that we need to think even about, so this is a problem not because a person or people are bad, but because the people just have different background, and so they live with this background and their philosophy as they were raised in. So this should be taken into account. This is a very nice paper how discussing different problems can be erased. So it was just an example. There were also other examples. And this is even the original bias, how it can be just be already incorporated in the data set. And so also there are right now a lot of papers. So one of the also recent ones that I can remember is about also kind of like bias in machine translation, for example. So we have, again, this very large multilingual models covering different languages. And of course, anyway, still one of the biggest monolingual parts in this multilingual corpus is anyway dedicated for English language. And there was a research that, so the name of the paper is something about that anyway, large language models has accent. So it was about if we want to translate something from other language into English, or anyway, even between languages. So we can see that the structure of sentences in language other than English anyway is English based, because as you remember, for example, for some translation models, it is done with translation from English language anyway. So yes, we have this anyway step, but we need to translate the English language and then translate it back. So so anyway, still sentences built in other language can have the structure from English language, and it's of course strange because it shouldn't be like this. So it's also kind of like a bias of language that can appear in generative models. So what else I can also recommend? So talking about text transfer, actually, there is also even a paper that already tried to transfer bias, so unbiased sentences, and I think it also can be found by indeed just text file transfer for bias. And it was actually done for news. It's a very interesting work from my perspective, because we also can think about applications that we can transfer, for example, emotions or propaganda style parts of sentences on news into naturalized one. And then we can refer with text that only tell us only facts, not with this some journalistic emotions that were also like mixed into this text. Yeah, so I think this will be my recommendation to read about and to think about.
Thank you. Is there any way for you to maybe share the links to what you were just talking about?
Yes, so actually, maybe not right now, of course. I don't know how we can organize this, but yeah, I can try to look for these papers, because yeah, I don't remember the titles exactly, but I remember anyway about what it was, Xavier, and then I can send you, or I don't know.
We're going to upload it. We're going to upload it to YouTube anyway, so we can also link the papers and the studies in the description, so people while they're watching, they can look them up. So just for the future when we watch the recording. Yeah, thank you. If there are no other questions, I would like to.
Actually, I don't know. I saw that somebody raised the hand actually. But yeah, we had some discussion and new question. So I don't know if the person wants to speak up or write a question in the chat.
If the person is still here, they can raise their hand again. If not, I would like to add something. I feel like your research would be really helpful to end on a positive note for clickbait, because even if something is not 100% fake news, a lot of the times respected media sources that do not spread overt propaganda or fake news, just because of ads and ad revenue, they need to force you to click on the article, so they have to use clickbait. So I think this would be really useful for people and just the general public to be able to differentiate, because a lot of people just read the title of the article. So I think this would be really useful for people to actually know if something is clickbait or the truth. So yeah, I think this would be really useful in this case. So yeah, I think if no one wants to raise a hand or ask any question, I would like to thank you. This was really interesting, really fascinating work, and we will upload it to YouTube so people can watch it. And thank you for joining us.
Yeah, so thank you very much for inviting.
Just a quick reminder to people for our next event that's going to be on the 10th of November with Vincent Bamadam from Explosion. It's going to be an online event, so we will have uploaded this YouTube video until then, so people who watch this can also join. So yeah, thank you once again, Daryna, and yeah, thank you for joining us.